Variables and expressions. A variable is a symbol, usually a letter such as X, Y, or Z. Different numbers can replace the variables to form specific statements. Now, an algebraic expression is a collection of numbers, variables, operation symbols, and grouping symbols, such as parentheses, square brackets, or fraction bars. For example, we have the expression x plus 5, the expression 2m minus 9. Now, our last example is 8p squared plus 6, parentheses, p minus 2, close parentheses. All of that represents an algebraic expression, whether they're simplified or not. Evaluating expressions. To evaluate means to substitute numbers in for variables. The resulting answer is called the value of the expression. First, we will substitute the given values in for the appropriate variables. And second, we will do the arithmetic necessary to obtain a numeric answer. So in our examples here, we have find the value of each algebraic expression if x equals negative 5, and then for x equals 9. The first expression we have is 6x. So if x equals negative 5, then 6x would be equal to 6 times negative 5, or negative 30. If, on the other hand, x equals positive 9, which is our second case, then 6x would be equal to 6 times 9, replacing x with 9, which would give us a value of 54. The next expression we have to substitute negative 5 and 9 respectively into is the expression 3x squared. Well, if x equals negative 5, then that means 3x squared is equal to 3 parentheses, negative 5, parentheses, squared. Now, order of operations would dictate that we evaluate negative 5 squared first, which is positive 25. So 3 times positive 25 equals 75. So if x equals negative 5, our value is positive 75. On the other hand, if x equals 9, then 3x squared is equal to 3 times 9 squared. Well, again, order of operations dictates that we would evaluate 9 squared. So this would be 3 times 81, which is 243. Next, we want to find the value of each expression for the given values. And our first expression is a rational expression. Okay, we have a numerator of 9x minus 8y. And a denominator of 2x minus y. And we want to evaluate this for x equals 5, and y equals 3. Now, as stated earlier, we want to separate the numerator and denominator, evaluate them separately. So I'm going to write this as 9x minus 8y all over 2x minus y as a quantity, as 9 times x, which is a value of 5, so 9 times 5, minus 8 times 3, because we stated y equals 3, all divided by 2 times 5, because that's our value of x, minus y, so minus 3. So this becomes 9 times 5 minus 8 times 3, all divided by 2 times 5 minus 3. Now, evaluating my numerator, I get 45, that's 9 times 5, minus 24, because that's 8 times 3, all divided by, now I have 2 times 5 minus 3, 2 times 5 is 10, 10 minus 3. So our denominator becomes 7, that's 10 minus 3, and our numerator will be 21. So we have 21 divided by 7, which is 3. For our last example, we have 2x minus 5y, and we're evaluating for x equals negative 10, and y equals positive 3. So that this expression becomes 2 times negative 10, that's our value for x, minus 5 times 3, our value for y. 2 times negative 10 is negative 20. 5 times 3 is 15, so this becomes negative 20 minus 15, or negative 35.